Okay. Hmm. I kind of want to recall how SVD works just by what I remember. So let's see if we can try to reconstruct this. So the idea is this. The main idea for a singular value decomposition is that for any matrix, we should be able to perform something called singular value decomposition. So for any matrix, let's say A in Cn by K, um, factorize it as um, A equals to some uh, maybe let's call it U sigma V like that. And let's recall the sizes. So if A is m by k, the sigma needs to be m by k, and this is going to be k by k, and should be n by n, and then because it should be a conjugate transpose like that. Okay, where U and V are unitary matrices. Okay, so right now I'm trying to think if this is possible. Okay, all right, I don't remember all this. Okay, and the sigma, this is a n by k matrix, and it looks like this: sigma 1, sigma 2, dot 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 dot, like that, where we can even arrange it so that sigma 1 is greater than sigma 2 greater than dot 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 dot, and these are all real. And in fact, all positive as well, right? I believe. Okay. And because this is not necessarily square, these are just occupied diagonal entries. So this is what I think what it should look like. Okay, let's put a big orange question mark here. So maybe this is how we do it, right? Okay. So how does this work? So this is what we want. So, well, why might this be possible? So let me put this in a cloud. Okay. Well, the idea that we can do this is because A star A is Hermitian, or a, complex conjugate adjoint, is Hermitian, which is another word for self-adjoint. Right? Because of course, if you were to take the adjoint of this. This is just a adjoint A adjoint, which is just a adjoint A. Okay, of course, finite dimensional matrices, just this adjoint is itself. Okay, so it's a self-adjoint uh, matrix. So by spectral theorem, A conjugate A star, I'm just going A star A, is um, I like to call these stars. Can we call these stars? I'm gonna call these stars. Because I'm just gonna say star anyways. Is orthogonally diagonalizable or unitarily diagonalizable. Unitarily diagonalizable. Okay. So what does that mean? That means that A star A should be equal to some U D U star. Okay. And the idea is that D would be sort of all, we can factorize this D. To factorize this D, so I might get A. Okay, UDV star. UD, yeah. Where do I want to put the star on the U? Doesn't. Well, let's say it's UDU star for now. Okay. We'll say a remark. Okay. If we have, if given A star A, okay, not just that the eigenvalues are real, they're also positive or non-negative. That has to be true, right? Indeed. If A star A x is equal to lambda x, some eigenvector, okay, then apply x star, right? So this shows that ax star ax, which is their dot product, the complex dot product is equal to lambda x star x. So lambda is equal to ax, well, basically norm of ax squared divided by norm of x squared. Right? Yeah, because we're just dot product with itself. Okay, which is greater than or equal to 0, right? Yeah. And this is an eigenvector. So eigenvector, it's not a 0 vector. Okay, so we know that the eigenvalues are greater than or equal to 0. Put a box around that. Okay. That's good. And so what? So if that's the case, we can factorize the diagonal. So let's say we have equal to u d u star. Now this u, this d, right? We have lambda 1, lambda n. This is diagonal. So we can write this as so what are just sizes, right? So if A is by K, A star A is gonna be K by K. So this is actually 2 lambda K. And so we can write this as U. And okay, so we're gonna say that sigma be this M by K matrix, and we just have this on a diagonal. Okay, and so if it's like fat, then we know we'll just terminate like this, and if it's tall, just terminate like this, right? So K is just whatever. Right, it's gonna be the shorter one. Now it's possible that we have zeros, but they're just gonna be zeros. Right, because of the ring. So we let, so there's some details here, but sigma to be this. So sigma star sigma. So let the sigma to the square roots. Then sigma star sigma will be this equal to this d. Basically, but factor this. So now we get u sigma star sigma u star. Okay. Um. So maybe